section of chapter 1 talks about 7 testing principles. People over the past 50 years suggested some principles that are considered as guidelines for software testing. The first principle is testing shows the presence of defect, not their absence. What does that mean? Using software testing, we can show the defects that are present, but we cannot prove that there is no defect. When we do testing, we don't find defect. That does not mean that there is no defect in the software. So testing just reduce the probability of undiscovered defect remaining in the software. But even if you don't find any defect, that does not prove correctness. A testing cannot be a proof of correctness. The second principle is exhaustive testing is impossible. Exhaustive testing means that you test everything. Test everything, all combination of input and precondition that we need. But our system is not feasible. It is impossible, except for the trivial cases. This can be exhaustive testing, but most of the time we can't perform exhaustive testing. So what should we do? We should perform risk analysis. We should choose proper test technique and prioritize them while we are managing our test efforts. The third principle, early testing saves times and memory. The best thing in software testing is begin testing as early as possible. So to find defect early, you should perform static and dynamic testing as early as possible. Principle number 4, defects cluster together. A small number of modules in your software are the reason for most of the defects that you discover while testing, or if that are not discovered and then discover in operational environment. So if you as a tester should detect the defect clusters and the actual defect clusters that happen while you testing, so that you perform risk analysis with this information to focus the test efforts. Principle number 5, be aware of pesticide paradox. Any pesticide that is used, if it is used over and over again, it will become weaker and weaker in killing insects. This is same for software testing. If the same tests are repeated over and over again, those tests will no longer be effective. They will not find any new defects. So to detect new defect, you should change your change your test cases and your test condition. If you will not change in your test condition, you will not find any more defects. Tests are no longer effective at finding defects, just as pesticides are no longer effective at killing the insect after a while. In some cases, pesticide paradox is useful in automated regression testing. Regression testing is that you change the part of software and this part cause changes or bugs in our part of the software. We prefer always to do regression testing in an automated way. So in this case, test cases are written in the history, will reused, and hopefully they will not find any defects. This is a good thing. If they find new defect, that means the system has regressed and there is regression, and we should solve this problem. There is only apply the automated regression testing, not normal testing. Principle number 6 is testing is context dependent. Testing changes from one field to other, from one project to other. Testing is done differently in different contexts. For example, safety critical industry. Control software is tested differently from an e-commerce mobile app. Because in safety critical industrial, software may be in hospital, someone may die because of our failure or bug. But our e-commerce mobile app, no one will die. we will lose some money and the problem can fix. There is no loss of human life. Another example, testing is an agile project is done differently than testing in a sequential life cycle project. The last principle of software testing is absence of error is a fallacy. What does it mean? It means that you think that there is no more error. Some organization or some manager expect that you as a tester, you confirm all the testing and find the possible defect. Principle 1 and 2 tells us that this is impossible. You as a tester, you cannot find all the possible defects. You cannot find most of the defects. So another fallacy is that you expect that when you find defect and fix them, and fixing a large number of defects will ensure that the success of the software. No. Why? Because, for example, if you test the environment and fix all the defect found, your system still can be defected. Your system still might not fulfill the user need and the expectation. Also, your system might be inferior compared to other competing system.